Hi, welcome back. We'd like to know whether two variables are related to each other. If one variable goes up, does the other tend to go down? Or if one goes up, does the other one go up? Really practical stuff. We have an intuitive understanding a lot of times of how two things might be related to each other. But if we really want to be precise, we're going to have to develop our toolkit. And that's what we'll do for the next few minutes. So here's an example of two variables, attendance in a class that I taught recently and the final grades for that class. And I use the scatter plot like this to generally kind of convey to students that attendance and final grades are kind of related. Now, I can't make a absolute causal claim that if you just attend class, you'll do better. But there does seem to be some kind of positive relationship between attendance and grades. Now, can we be more precise about it? Yeah, we will in just a moment. So we're going to look at two main different measures of association between variables, covariance and correlation. And both of these variables, these statistics, kind of measure the strength of the relationship between two variables, but in a particular way, and it tells you whether there's specifically a linear relationship. Can be positive, it can be negative, but it won't show you all kinds of different relationships, just the simple ones, the linear relationships. So what do we mean if something is a positive covariance, like if x and y are positively covariant? Well, that means that when x tends to be high, like specifically above its average, when x is high, then y is high. Conversely, if x is low, then y tends to be low. If that's the case, then you'd say x and y have a positive covariance. If x and y have a negative covariance, then the opposite thing kind of holds, that when x is high, y is low. Or when x is low, y is high and tends to be above its mean. Now, this slide looks daunting, right? But I'll walk you through it. It's not actually as difficult as it looks. The first thing that I'd like to point out is that first line is the definition of variance. Now, if you don't remember variance, please look at one of the older videos. I'll have a link for that. But what I'd really like to show you is this relationship between variance and covariance. So specifically, if you look here at this particular definition of variance, you'll see that, so it was the difference of each observation from its mean, but then it's squared. So I'm just going to write out this squared term like here. So, the thing times the thing. That's what it means to be squared. And if all we do is take this formula, but replace one of these x's with the other variable that we're interested in, if we replace this with a y, then that's the formula that we got. So it really is just a variation on a theme. And so how would we apply this? Well, this is saying that we want an average of terms like this, right? So we're adding up those terms, all n of them that we have, and then dividing by n. We know that's how you calculate an average. You've got 3 exam scores, you add them up, divide by 3. Here we've got n things, and we're going to add them up and then divide by n. And those things are these things right here. Okay. Now what are these? This is each particular x variable and its difference from its mean. So these are distances of each observation from its mean. All right, so that's the x term, and this is the y term. So, for example, if I had 3 students, I would take attendance from student 1 minus the average attendance times that particular student, student 1's grade, minus the average grade. And I would do that also for student 2. Attendance for student 2 minus the average attendance for the whole class times the grade for student 2 minus the grade for the whole class. And then we would do that for student 3 and student 4 all the way to student n, right? So you would do it all the way through student n. And do all of that and then add up all those terms, and then you divide by n. And that's your covariance. So yeah, it definitely looks kind of hairy, but if you understand variance, you understand covariance. You're really literally only replacing one particular x with a y. So here's a made-up example. Let's say we had an entire class, and I asked the students how much did they study for a midterm or something, and then I recorded the hypothetical students' grades, and I've got those grades right here, and then I just kind of graphed it here. And the reason I graphed it is just so visually that you can see that there seems to be some kind of, there's like this positive relationship here between these x variables. Now, how positive, we'll get to that in a second. We want to work with this toolkit. So, so we want to calculate the covariance. I know that it's going to be the sum of a bunch of terms, and each of those terms is the difference of each value from its mean. So we need to calculate the means. So let's do that real quick. So what is the average of x? So it's 4 plus 6 plus 5 plus 5, and all of that divided by 4. So we've got 10, 20 divided by 4. The average x is 5. Now what about the average y? You have 80 plus 90 plus 85 plus 80, all of that divided by 4. And if you plug that into a calculator, you get 84. Oops, there we are, 84.5. So we're going to need that information for our covariance. Now, what's covariance again? We're going to take each of our observations on x, subtract off the mean, multiply the corresponding observation on y, subtract off its mean, add up all those terms, and then divide by the number of observations, which in this case is 4, because we've got 1, 2, 3, 4 observations. So let's plug in some values then. So let me get my little pen. Here we go. All right, so here we go. It's going to be 1 over 4, because n is 4. And then we've got the first x. That was 4, minus the average, which was 5, times the y value of 80, minus the average. Okay. So that's our first term in this average that we're calculating. We need to do the same thing for all of the students in this hypothetical class. The second student here was a 6 with a grade of 90. So that's our second student. Our third student had a grade of, studied for 5 hours and got a grade of 85. So 5 hours, oops, minus the average, which was 5. Study time, the difference of that student's study time from the average is here. And then 5 minus the average, which happens to be 5. And the last student's grade and how far away it was. Okay. So we'll just plug in some numbers here. Oops, where's my pen? There it is. So we'll plug in some numbers. We get 1/4. 4 minus 5 is -1. 80 minus 84.5 is a -4.5. 6 minus 5 is 1. 90 minus 84.5 is 5.5. And then we've got 5 minus 5, which is 0 times something. This 5 minus 5 is 0 times that. And the zeros cancel. Okay, so in this case we have 4.5, negative times a negative makes a positive, plus 5.5. All of that divided by 4. Okay, so that's 10 divided by 4. Which is 2.50.